Hello everyone, welcome to this most exciting lesson by Say Mutawani. In today's lesson, we are going to learn about graphs. In this new chapter, we are going to cover linear quadratic functions and functional notation objectives. By the end of the topic, you should be able to draw up table values for given linear functions, use them to draw straight line graphs on the Cartesian plane. Again, you are supposed to be able to read off values on straight line graphs and draw up a table of values for given quadratic functions, as well as to use the table of values to draw the graphs of quadratic functions on the Cartesian plane. And again, you should be able to draw a smooth parabolic curve to join plotted points. And again, you're expected to be able to read off values from graphs of quadratic functions, including maximum and minimum values. And lastly, you are going to supposed to be used functional notation. Linear graphs. Linear graphs. Lesson 1. Linear functions. Draw the graph of y is equal to 3x minus 2 for values of x from minus 2 to 4. Use the graph to find y when x is equal to 1 minus 1.2 and to solve the equation 3x minus 2 is equal to 4. Now we need to first fill out the table of values from minus 2 to 4 like this, and then calculate the values of y for each. We're going to substitute minus 2 in the equation. Y is equal to 3x minus 2. If we work out like this, y will become minus 8. Then we write minus 8 here. And then if we substitute negative 1 for the value in the equation, we will write y is equal to 3x, 3 by negative 1 by minus 2 like this, and we simplify to negative 5. Continue to substitute the values, pause the video and calculate these values and see if you come out with the true values. Okay, now these are the true values: minus 2, minus 1, 4, 7, and 10. Now let us now draw the graph of y is equal to 3x minus 2. Here is an overview of a graph paper. I'm going to explain a little bit about the graphs. The graph paper looks like this. This got a square of 2 centimeters this side and 2 centimeters this side, and each square has got 10 small divisions. Let us count them together: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 10 upwards. So this forms a 2 square centimeter box with 100 small boxes inside. So when drawing graphs, you need to choose an appropriate scale so that if you draw your graph, it must suit on the specific paper you have. For instance, if I have got some readings from 0 to 100 in this case, I have to choose how many boxes do I have here: 1, 2, 3, 4, 5. So I can choose a scale of 2 centimeters to represent 20 centimeters, so that if I say 0, that's 20, 40, 60, 80, and then 100. It will suit on the scale. That's how you implement. On the x-axis, the same. You have to choose an appropriate scale to suit on the horizontal axis. That's how you choose the scale. Okay, now let us draw the point. See how we can draw on the graph paper. Right, the y values are ranging from negative 8 to positive 10. So that's how we draw like this. And then this is the x-axis and then the y-axis. Then 2, 4, 6, 8, 10. I've chosen this as my appropriate scale on the y-axis, and the 2 centimeters to represent 1 unit on the x-axis. 1, 2, 3, and then 4, and then negative 1, negative 2. So you can continue to fill out the negative values on the y-axis. Let us now plot the points, starting from the upper values 4 and 10 on the 4 for x-axis and 10 for y, like this, 4 like this, and then 10. Where these 2 points intersect, that's where we will plot our point. This point, that's how we do it. So likewise, we can continue for all the points 3, 7, and put a plus sign on the point of intersection of the 2 points for 3, 7 like this. 3 for x, remember that don't interchange this one. And then we'll plot like this. And then we continue for 2, 4. This is the point for 1, 1. For 1, 1, this is the point. For 0 minus 2, this is 1. We can continue for the negative values and to plot we join the points like this and write the equation y is equal to 3x minus 2. So let us zoom out to see the graph paper in full. All right. So this is the sum dv graph. As you can see, this point is plotted 10 for y and 4 for x. As you can this, let me scroll down and for you to see all these are the points: 1 for x, 1 for y, and 0 for x minus 2 for y. And this is the point minus 1, minus 5, and lastly this is point minus 2, minus 8. So this is our graph. Taking a short break, we'll come back soon. All right. Are you finding these lessons helpful? If so, please hit that subscribe button. It's completely free and will help me create more valuable content for you. Your benefits as a subscriber. Number 1, easy access. All my lessons will be saved in your subscription feed for easy viewing later. Instant updates. Number 2, you will be the first to know when I release new lessons. Let's grow this community together. Hit that subscribe button now. It's free. Thank you. Now let us continue and simplify the part questions of this one. So the first part of the question reads, find y when x equals to negative 1.2. So we move to negative 1.2 like this, and then we draw a straight line from negative 1.2 on x until we reach the point on the graph, and then we take a look at the graph. So y is equals to negative 5.5. Let us see on the graph. All right, on this graph, part A, minus 1.2. This is minus 1.2, and we've drawn the line until we reach the point on the graph y is equals to 3x minus 2. So this will, after reaching the graph, we'll tend to see the value on the y-axis. This is this is negative 5 at this point, negative 5.2, negative 5.4, negative 5.5. So this is negative 5.5. When x is equals to negative 1.2, y is equals to negative 5.5 from the graph. On the graph, all right. So from the graph, y is equals to negative 5.5 on x is equals to negative 1.2. Part B of the question requires us to solve the equation when it is equals to 4. It simply means that finding x when y is equal to 4. So we have to move on from this point, part B, and then reach and see the value of y. Let us take a look on the graph. All right. All right. Part B of the question requires us to find x when b is equals to 4. So this is b when y is equals to 4 like this. So we have to move on until we reach the equation line, which is this one, and then we turn out to look for the value of x, which is positive 2. So we have solved the equation using the graph. X is equals to 2. That is the root of the equation. Head over to the accompanying exercise for this lesson. This interactive exercise will help you solidify your understanding of this lesson and ensure you are exam ready. Get immediate feedback, results, corrections, and solutions to the challenging problems, all designed to make you a math whiz. Not enrolled in the full Form 3 math course yet? Now is the perfect time. Visit mugombeonlineschool.com and unlock all the benefits, in-depth lessons, interactive exercises, and the mastery of Form 3 mathematics. See you in the next lesson. Goodbye.